Okay, everybody, this is section 7 in chapter 10. This is the last section of the chapter. Okay, so for an area of a circle, some of you guys have probably done this before, but let's go through this really quick. Formula up here for the area of a circle is pi times the radius squared. Once again, we're going to go ahead and say pi is going to be 3.14. The radius is going to be from a central point in the circle to a point on the circle, so that would be a radius. A diameter is a line that goes through the center of a circle and is connected by points on the circle, so that's going to be a diameter. Okay, in my formula up here, I need a radius. So in this case, when they're giving me a diameter of 10, I need to cut that in half and get a radius of 5. So I do need to have a radius for this, okay? So going ahead, they want me to find the area of the circle. So the area is going to be pi times the radius squared. I'm only squaring the radius. A lot of mistakes are made by squaring everything, okay? So I'm going to go ahead and square 5. That gets me 25. I multiply it to 3.14. And I'm going to get an area of 78.5. They are giving me as inches my units, and it's an area, so we're going to square it. Okay. So you probably have done that before. Just need to have a radius. If they give me a diameter, I got to cut it in half. Okay. So this is going back to kind of that arc thing that we did in section 6. I have an arc between 2 points that are on the circle. It's created by an angle. It's the central angle. The angle is created by the center of the circle. And what that does is create something called a sector. So think of it as a piece of the pie. So if you like cherry pie or banana cream pie or whatever kind of pie, it's going to make you hungry. Anyways, it's a sector, and I want to find the area of this piece of the circle. I know. And it's going to be proportional or similar or a ratio of the entire circle. So once again, this is similar to what we did last time. The circle is represented by 360. I'm going to need the measure of that. That's going to be in degrees. So if I get an angle measure here, let's say it's just 60 degrees. Well, the arc is also going to be 60 degrees. Okay, so I'll need that. And then I'm going to multiply it to the area of the circle. Okay, so last section we multiplied it by the circumference because I was finding, I'll use this circle down here. I was finding the length of that because it was proportional to the circumference of the circle. Well, now I want to get, the piece of the pie, it's proportional to the entire circle. Okay, so coming down to example number A. I'm going to find the area of the sector. We'll just use capital A for that. The measure of the arc that's created by the 2 points here. They didn't give us any letters, but that's going to be 80 degrees. And I'm going to put it over 360. I'm going to multiply it by the area of the circle, so that's going to be pi 3.14. The radius in this case they're giving me is 4, so 4 squared. Okay, I'm going to go ahead and multiply that all up, and like I said before, this fraction, I just tend to reduce it. You could turn it into a decimal, whatever you like to do. I reduce it down to 2/9, and then I multiply this all up out here. It's 16 times pi, gives me something around 50.24. I kind of leave it to the hundredths place because I'm using pi. I'm okay if you just round it to 50.2. We'll be in the same ballpark, okay? And then I'm going to multiply that all up, and I get about 11.2. And they gave me units in feet, and I am finding an area here, so it's going to be feet squared, okay? So just that little piece is an area of the entire circle is proportional to what the area of the whole circle would be. Back here I found the area of the whole circle. That helps me get just that piece of the pie. Okay. So in example B, we're going to kind of do kind of the same thing. It's a smaller piece of the pie, and they give me an angle. Now, if it's 24 out here, then it's 24 in here too, okay? So the area is going to be 24 over the circle, 360, times the area of the circle, so pi. They give me a radius of 14 squared, okay? You can go ahead and change this fraction to a decimal if you want, or you can go and reduce it like I do. I get 1 over 15. I'm going to multiply 14 squared is 196, and multiply that by pi. I get approximately 615.44, and I went to the hundredth because of pi. You could have just said 615.4. I'm okay with that. I'm then basically going to have to just divide that by 15, and I get approximately 41. In this case, they didn't give me any units. I'll just stick with feet because that's what the previous problem was, 41 feet squared. Okay. So you're finding just a piece of the pie, and the pie is proportional to the entire circle. Okay, so that's where this formula comes from that we got there in the box. Okay, so pretty easy. I just need some information. I just need to stick it in there and do some math. It's pretty basic there. But this question that's next is kind of cool, and you'll see this again. I want to find the area that's shaded. So I need this little piece here between A and B, but it's like bordered by the edge of the triangle that's created there. I don't know if you guys see that. Between A and B, I could also just draw a straight line. That gets me a triangle, okay? Now, a couple cool things, or not cool things because you guys don't like my coolness here. This is an 18, and it's a radius. Well, this would have to be 18, and it's a radius. If this is 60 and these two sides are the same, then these sides have to also be 60. So that's telling me that this is going to be 18 also. So I have an equilateral triangle in there, okay? If we go back up to this diagram up here, it's kind of giving us a clue to how to proceed here. Find the area of the sector, so that's kind of what we just did. Find the area of this triangle here, so we're going to kind of play with that, and then I subtract the two, and it gets me this little shaded part that was in here between the arc and the edge of the triangle. Okay, so it's just kind of showing us how to do it. So let's start with the area of the sector. I'm going to need the central angle. It was 60 degrees, and I'm putting it over the circle, 360. I'm going to multiply it by the area of the circle, so pi. The radius was 18 squared, okay, and this is going to get me my area of that sector. So I'm kind of ignoring that shaded in part for a second. This is going to reduce down to 1 over 6. I'm going to multiply all this up, so 18 squared times pi gives me approximately 1017.36. I'm basically going to divide that by 6. Okay, and I get about 169.6. I rounded that. Okay, really good there. Okay, I'm going to draw this triangle over here that we got there. It's an equilateral triangle. These are 18. This was 60. Therefore, this had to be 60, and therefore this had to be 60 because the triangle's got to equal 180. So this is going to be 18. Okay. To find the area of a triangle, it's base times height divided by 2. If I do this to get the height, well, then everybody goes, oh no, it's a special right triangle because now this is 30, okay? If I split this, this is going to be 9 and 9. And so get the height using special right triangles. The height is going to be 9 square root 3 because that would be the longer leg, okay? So I've got a base of 18. I got a height of 9 square root of 3. I'm dividing that by 2. Okay. Now what I'd like you to do is take the square root of 3 and multiply that out. It's about 1.7, blah, 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 blah. multiply all that up and divide it by 2, and you should get around 140.3. Okay, so I've got over here, I've got the area of the sector. Over here, I got the area of the triangle. And my concept's telling me to subtract the 2 to get the area. They're calling this a segment of the sector. Segments created by the endpoint here and the endpoint here and the border of the circle. Okay, so I want to take the 2 answers that I got, so 169.6, subtract 140.3, and that will give you my answer. So approximately 29.3. It's an area. In this case, it was inches, so it'd be inches squared. Okay, so that problem will show up again, and you know, it's the process. You just got to get your way through the process. You know how to do all the pieces of it. Now you just got to put the pieces together. Okay.